All right. Well, now you get the joke, or you don't get it. So, because there's 2 types of people. Well, 10 types. All right. We are going to talk about triangles. Triangles are going to play an important part in electricity for us. You wouldn't think that, but it is true. Especially when not especially, when we get into electricity, because it has nothing to do with DC current. It has everything to do with AC current, and that's where we will get into triangles and manipulating triangles, because triangles represent AC current. And not that this is something you need to know right now, but the way it kind of works is with alternating current as opposed to direct current. In direct current DC with batteries, direct current just goes straight. Resistance, all you have is resistance in DC. There's nothing else to it. But when you get into alternating current, where it alternates back and forth, it goes positive, then negative, positive, then negative, we have 3 components that we have to look at. So we have resistance, well, since we have a lot of components, but on the sort of in the resistance category, we have resistance, which is represented by the bottom of a triangle. And then we have inductive reactance or capacitive reactance, which would be X of L or X of C, depending on if you have more coils or inductors or motors or more capacitors. So this is a real problem with, my father-in-law worked for SMUD, and so when you add motors to an electrical circuit, it starts to throw it out of phase. So, and we'll get all of this when we get into electricity, but just so you can kind of get a precursor. So what happens is with DC current, we don't think about voltage and amps being separated. I mean, you just have amps and you have volts. Measure the amps, measure the volts. But because in alternating current, go up a little bit, you have, it swings back and forth. Like this is 0. So it's going to go to a positive, then it swings negative, positive, negative. So the voltage is really going back and forth constantly. It's almost like if you took your battery and the leads on the battery and kept doing this to it, right? It goes one way, then the other way. Well, the voltage does that, and then the amps does the same thing. But in theory, hopefully, the amps kind of, I want red. There we go. Thank you for that. The amps, which isn't as much, should kind of do the same thing and meet back here at 0. And then, of course, amps isn't as much, and then come back and meet at 0. So that would be an in-phase circuit. But what happens is it doesn't always do that. And we can get the 2 out of phase where, for example, we have voltage. Great, didn't switch again. I have voltage doing that. And now amps will be black, sorry, because the pen didn't work. It could be way out of phase. So it could be starting here. One could peak out here and do that. So now this one's peaking over here where it should be at 0. This one is peaked here where this one's at 0. So that's an out of phase circuit. And so when you add a bunch of L is inductors, which is coils, which is motors. If you add a bunch of them, it starts to throw things out of phase. And so my father-in-law was telling me at SMUD, they actually have these gigantic capacitors, and the more we turn on our electricity or our air conditioners and running motors, the more it's going to out of phase. Well, then SMUD's job is to start adding capacitors, which makes it go the other way. But in a circuit that would have too much of one or too much of the other, that would be the up. So this is resistance here. And then your X of L or X of C, which is inductive reactance or capacitive reactance, that line starts going up, the worse it gets. Then what you're left with in a triangle is this right here, which is called the hypotenuse, which is Z, which is impedance. And an impedance is what ultimately gets represented as resistance. So it'll make a lot more sense when we get there, but that's not for several weeks. Yeah?
For AC, what if the 2 patterns are completely out of sync, point where one goes down and one goes up?
Then it's an inefficient circuit. It's a good question. Yeah, it becomes very inefficient. And when we get into AC, we'll do that. We'll do a power factor, and we'll see how inefficient it is. So we want it to be back in efficiency. So that's what happens there. So anyway, to analyze AC circuits, you end up doing a triangle where you have to, you want to ultimately get Z, which is like R total, if you will, but it's not, because we have real R, which is real resistors, and we have the inductors and capacitors, and then what's left over is Z. So in these triangles, such as this, we work with what is called a right triangle, which means that this right down here is 90 degrees, just because that's the way it's set up. And the other names of the we need to be aware of with a triangle, let me see. When referencing, well, this is the hypotenuse. And I don't remember if I spelled that right. Let me see. Hypotenuse. Hey, I got it right. Hypotenuse. So this right here is the hypotenuse. And that's the important thing to know. And I'll draw another one here. So we have right here. So that means it's a right triangle. It means that's 90 degrees. It'll just be assumed from here on out. So when referencing this spot right here, because this angle right here is ultimately going to become our angle of theta, which is going to represent our phase angle of what we're going to be looking for in electricity when we get there in a couple of weeks. So you could imagine, if you can, or if not, I'll just draw it. If x of L and x of C equaled each other, they cancel each other out, by the way. X of L is up and x of C is down. But I always draw the triangle just up. If you had an equal number of x of L and equal number of x of C, all you would have is resistance, and there would be no x of L or x of C. So the hypotenuse angle would be basically this angle right here, which would end up being 0. So you're in phase. So, but when you get out of phase, then you want to know this angle right there. And so our job is going to be to find that angle. And I think my mouse just died or something. Oh. I think I need more memory in this computer. It's not like to play along.
A new computer already?
I think I'm just overtaxing it or something. Okay. That and this mouse is blinking red. I mean, it could be that. Red is good, right? Means continuity. Okay. So, lost my train of thought. So we're have to figure that out right there. The angle. So that is the phase angle, and the worse that is, the worse the circuit is. So let me see. We have, well, if I looked at this drawing I have right here in front of me, which is backwards. Maybe it's just the fact that I've drawn so much on here.
What is that you drew right there?
That right there, angle of theta, which is a Greek symbol, which I didn't draw very well. All right, so the drawing in front of me. Well, it labels this right here as, probably shouldn't do this, but a big C. And it gives this one up here the big letter B, and this one over here the letter A. And it gives, let me see, B to C. It gives this one an A, and it gave the hypotenuse a C, and this is the base of a B. And according to this, let's see, this triangle is a right triangle because angle C is, how many degrees? 90 degrees. And by the way, if I added up the angles, whatever they might be, of C, B, and A, all three angles will always equal 180 degrees. All right, let me see. So referencing A, which is what's important to us, this is the, right here, that'd be the opposite. This right here would be the adjacent. Yeah, just screw that little A, B, and C. And this one is known as the hypotenuse. So, especially when we're referencing from A, and that's what we're always going to be doing, because we don't need to make this more complicated than it is. We're always going to talk reference A. So over here, this is the opposite. A is opposite A. Down here is Adjacent, which means next to. So we can look at that. Well, this line here is next to. It makes sense because hypotenuse is always the hypotenuse. So all you have to do is remember adjacent, so one next to it, and what's left over is the opposite, which is on the other side. So, all right. So to figure all of this out, we're going to be using not only arc sine, arc cosine, arc tangent, but we will be using Pythagorean's theorem. So let's talk about that. Yes?
So when you say arc, sine, cosine, tangent, is that different from
Sine, cosine, tangent. It's like on our calculator, it's sine minus 1, sine minus, or cosine minus 1, and tan minus 1. And I'll come back around to that a little bit. So Pythagorean's theorem. Py. I have no idea how to spell this. I'm not going to pretend like I do. Py. There we go. Thagorean theorem. It was named after Dr. Albert Theorem, a Greek philosopher. I don't know. Which is, the formula is a square plus b square equals c square. And c is always going to be the hypotenuse. And a and b are going to be the opposite. Now, it really doesn't matter which one, as long as c is always the... I'm really on the struggle bus on my computer here tonight. As long as c is always the hypotenuse, and a and b are the sides. So, what would be my hypotenuse? What would it be if, let me see, if I had, we'll make that 7, and that's 9. And we don't have to get into inches or feet, it's 7 and 9. Be millimeters, centimeters, whatever you want it to be. So what would that look like?
7 squared plus 9 squared.
Thank you. 7 squared plus 9 squared. So we would just say 7 squared plus 9 squared equals
C squared.
c squared. All right. Well, we just got to do the work right here. So 7 times 7 is about 49. And 9 times 9 is 81. That would equal c squared. Right, we can't just put the equal there. And so those two numbers together will equal 130 equals c squared. Well, we got to get rid of this squared over there on the c, don't we? And how do we do that? We use the square root because that just cancels each other out, but we can't. We got to do that over here, and there's nothing to cancel out. So we really have to figure out what the square root of 130 is, and that happens to be 11.4. All right. That's not too terribly hard, is it? So that's 11.4. All right. Oh, good. I have another example. What if the length of the sides is 7 and 9? That's a duplicate there, buddy. Wait, what if the length of the side is... Oh, I see. I did do something. What if, that's what I did, I made a new triangle, but I used the same numbers, and I just said, what if this is 7 and this is 9? What is this going to be?
7 squared plus
So a squared plus b squared equals c squared, but now it is...
7 squared plus b squared equals 9 squared.
Okay, I was going to go a squared. Doesn't matter. You can do 7 squared. You can do a squared. I'll just make this one here 7 squared because that's what I wrote in my notes. So I don't screw it all up. Equals 9 squared. And so a squared plus 49 equals 81. Well, now what? That's a mess right there and a half, isn't it?
Subtract 49 from both sides.
Why not just subtract a squared?
Yeah, that'd be a lot easier.
That'd be really easier, wouldn't it?
Yeah.
Yeah, then it's just 49 equals 8. I'm just kidding. So, no, I'm just messing with him. He's like, I don't know if he's serious or not. Yes, we want to isolate the a squared. So the easiest thing to do is, well, just get rid of the 49, right? So if we minus the 49, well, we got to do it the other side too. So minus 49. So a squared equals 32. And now we know what to do from here, right? Square root, square root. So a equals 5.66. So right there is 5.66. Yes.
I thought, can you go up? I thought the height was A, like 7.
Doesn't matter.
Oh.
My point was it doesn't matter. And that's what I said. It doesn't matter if you do this one or that one.
Oh.
And then when I plugged it in, I said, yes, 49 should go right here, the 7 squared. But since I wrote it in my notes kind of funky, I'm just going to do what I wrote in my notes. Therefore, I don't screw things up.
Okay.
It was everything I said was sort of important there. So, or I could just redraw it. Make that 7. Make this the unknown. There you go. Now I'm better. I just wrote it funky. So, but that brings up a good point. It doesn't matter, does it?
As long as the hypotenuse is still the same.
As long as C is the hypotenuse, it doesn't matter. So that's one less thing we have to worry about, isn't it? Because it's not a math class. It's electricity class. So, all right. Well, all this next part of my notes is all about what I already talked to you about in electricity. So, are we good with finding Pythagorean's theorem here? Working with that? All right. So, we take it to the next step. And sine, cosine, and tangent is used when you know the angles of a triangle. When you know certain angles, you can figure out the lengths. But we don't do that. We work it backwards. So for us, we're always going to have to be given our, at least the 2 lengths. We're always going to be figuring out resistance and our x of L or x of C. And then from there, we can easily figure out the hypotenuse. So we end up with a triangle. And let me see, do I have, oops, I just got ahead of myself. So, okay, no, we don't. So if the above triangle has sides that are, let me see if I can get this right here. Okay, 65. So that'd be like 65 ohms, really, if we thought about it. But where we're going to go to, and we'll say this has a side of 35. And if it's going up, technically it'd be x of L. And over here we'd have, well, let's just, for fun, why don't we figure out, instead of me telling you, what is the hypotenuse then? So a squared plus b squared equals c squared. And so we have 35 squared plus 165 squared equals c squared. And I'll let you kind of figure out the rest for me.
The answer is 40.
Well, let them have it. Just a minute there, Skippy. You looked at my notes, didn't you? It's a reflection. You guys get it? What'd you get?
5,450.
No, it is not 5,450.
73.824.
That'll be a little bit much. 73 point.
824.
All right, we're just going to call it 73.8. So if you got 73.8, good job. If you got 5,000 and how much? You're almost done.
That was before I squared it.
I know, it's before you got the square root, you mean.
Yeah, squared it.
So you're close, you just weren't finished yet. Okay, so does anybody remember what 73.8 represents? Okay, 8's the hypotenuse, but if we're talking electricity, it was Z, or impedance. Okay, so now I have to figure out this phase angle right here. That's important to me to know how, from the phase angle, I can figure out how I can analyze the circuit if it's how bad it is, really. You can just look at it and go, that's not good. So what we're going to do is be using these functions. So we have arc sine, which is sine minus 1 on your calculator. Make sure, yes, sine minus 1. And it is, the formula is opposite over adjacent. I'm sorry. Nope, don't write that down. Hypotenuse. And you will not have to memorize this. I will never, there's a thing called SOHCAHTOA. So if you remember SOHCAHTOA, and I'm just gonna be honest with you, I can tell you it's SOHCAHTOA, and I'll show you in a second. So arc cosine, or cos minus 1, and that is adjacent over hypotenuse. And we have, last but not least, arctangent, or tan minus 1, and that is opposite divided by adjacent. And so when I said SOHCAHTOA, it is S sine SO ka TOA. And for the life of me, I just, for whatever reason, I always screw that up. So, but you could, oops, that should be capital T. But anyway, you see where that comes from. So if you remember SOHCAHTOA, which I never can remember to say it, but then I'm like, so, that's, how are you going to spell so this time? And then COA would be C-O-A to me. So anyway, so I will always give this to you. When we get into doing AC, we're going to have a long list of formulas. And just so you know, the way and I think I've told you before, the way I work it is you as a class before the test, I'll say, what do you want to know? And then you guys will tell me all the formulas you want, and I will write it up on the board. So at some point, you'll just be taking a test, and you'll look up and go, oh, look, he wrote arc sine, arc cosine, arc tangent. If you want that on the board, I will be happy to give it to you. But looking at all of this, what we do with it is this. We want to figure out this angle. And we can use sine, cosine, tangent, arc, cosine, tangent, all three of them. It's completely up to you which one you want to do. Now, we'll do all three of them. So the way we would do this, we would look at it and say, okay, what is, I wish I didn't have all this written over here. Let's see, there we go. What is, let's see, you want to do this. What's the opposite?
65.
Opposite is not 65.
It's 35.
35. And what is the hypotenuse?
73.8.
73.8. So what we do is we do second sine 35 divided by 73.8, close the parentheses, equals 28.3. 28.3. That's degrees. That is the angle. It was that easy. So this angle right there is 28.3 degrees. Yes?
Just one more time, how you got the cosine in there for this?
Yes. All right. So on your calculator, clear. Second tan. I'm sorry, second sine. Second sine. Got it? Second sine. And so you should have a parentheses. Now we're just going to plug in what we 35 divided by 73.8, which we got from here. 35 opposite divided by hypotenuse. Close the parentheses. Equals. Got it?
Yep.
Awesome. Well, let's just say we didn't want to use sine because we don't like it. And we want to use cosine. So then all we're going to do is put second cosine adjacent, which is what?
65.
Divided by
73.82.
73.8 equals,
28.2.
I'm really hoping it's around 28 point something.
It's
28.27 rounds up to
28.3.
28.3. They're all going to be a little bit different. All right, and everybody got that? Now we're just going to do it with the tangent, which is
Second tan.
35.
second tan. Opposite. What's the opposite?
35.
35. And what is the adjacent?
65.
65. Equals
28.3.
28.3 degrees. So you see, that's how you're going to work it.
Can you go back up for just a second, real quick? So
Mhm.
you're solving for the angles right now?
Just this angle right here.
Okay. Oh, okay. So, I understand. So those were all for that angle.
all for that angle. It's the only angle we care about in electricity. Well, this angle right here is a given. It's 90. And then we
Right,
could
that's why I was a little confused. I was like,
get that angle. We just subtract both these from 180 and get that one if we wanted to, but we never need to.
So as long as you have two of the numbers, you can solve for that angle no matter what.
Exactly. You don't really need the hypotenuse.
Yeah.
So this brings up an important point when we get to electricity. It's completely up to you, but you'll eventually figure out the x of L or x of C and your resistance. Then you have to compute the hypotenuse. Then you will compute this angle. Well, what if you screw up on the hypotenuse? And you use sine or cosine to get the angle?
Completely wrong.
Then you're wrong in two spots. But if you get x of L and you get R, and you screwed up on the hypotenuse, you miss one. But if you use tangent, which is opposite adjacent, not hypotenuse dependent, you'll get that answer right. Then you could take it one step further and go, well, let me just see. If I've got 28.3 right here using that, let me plug in my hypotenuse and see if I get the same answer. And if the hypotenuse comes, using hypotenuse comes out way off, and you're like, whoa, wait a minute. I screwed up somewhere, and you can back up and check yourself. So, all right, let's see what I got in my notes here. All right, let's do this then. I'll let you figure this out. Find the, I'll just give you a triangle. And I will say this is 25 and this is 50. So what is, we'll just call it Z to be really cool, and what is the angle? Angle of theta. Yes.
What would be considered a lot for the angle to be off by in AC?
I don't know. The more it is, the worse it is. So I think you'd want at least a single digit, not 100%.
Okay.
Not an electrical engineer. I just fix the damn stuff.
Passes current.
You guys all done? Yeah?
Yeah.
All right. Those that aren't done, they're just staring at the paper, not hearing a word I said, so that's fine. Serena, you're down. You done?
I'm
Done?
done.
Kyle? Yep? Okay. I don't care about this side. All right. A squared plus B squared equals C squared. So let's see. We got A is 25 squared plus 50 squared equals C squared. So let's see. What is that? 2,500 plus, nope. Well, I got it backwards here. Sorry. Plus 625. I just wrote it backwards. My bad. Equals C squared. So that is what, 3125? 3125 equals C squared. So I have the square root of both of those. What does that equal? 55.9 is equal to Z. So now we want to know that angle. Which one should we use here? Tangent. Okay, so
Since those are
10 minus 1, which is Let's go up here. Tan minus 1 is opposite adjacent. Got to make sure you have it on the right side. So opposite. Adjacent, so the opposite is 25 over adjacent 50. So that is, let me see, clear second, 10 minus 1. What'd you get? 26.6. So I'm going to go 1 decimal place. Well, how are we going to check our answer to make sure that hypotenuse is correct? All right, let's check it against sine. So arc sine, sine minus 1. So we have 25 divided by 55.9 equals 26.6 degrees. So it checks out. So that's what I would do. But that's just me. So, all right. Everybody's comfortable with that?
Yes, sir.
Good deal.
I have a question. So
I'm sorry. All questions need to be submitted in writing. At least 24 hours in advance.
why do we use like sign negative 1 instead of the sign button?
Because the sine button's the opposite function. It's to find the side when you know the angle.
Oh.
And I used to teach that, and I'm like, just too much. It's like, we don't need it. So, but yeah, that's what that is. All right, what else I got here?
This is not going to be on the test, right?
Yeah,
Or is it going to be on the test?
yeah. Yep. Do I need to start again?
Borrow somebody's notes.